So that's kind of that. And I'll talk a little bit, I guess, now, because this next slides that I have.
Yeah, I just want to repeat Tim's question really quick. So the question was, if that pellet was sitting on the dash of his car on a hot day, would it melt or not? It sounds like the answer is no, but it must have a melting temperature. I mean, there must be. Have you done the melt test?
The melting temperature to reintroduce the melting point is 250 degrees
Fahrenheit.
Yeah.
Okay, so I mean it's hot enough, but yeah.
Yeah.
Not crazy hot. Okay, thanks.
These next slides they're just real easy. They're just they basically tell my story. Transportation. There's my wood incoming. There's my my rail. I show you this because I just told you about how long it takes to burn and turn to the port of Longview, which is what we were going to do if we were going to go to Asia, either Japan, China, or. And so this slide here just demonstrates how long it takes to get running a couple of mountain passes through there. You know, it's fairly robust, and your problems that you come into is the Tri-Cities right here, and it gets held up there. Coming through right here is the big pass that it has to go through. So there's just a lot of things that that we would have to do in the western states that they don't have to do in the Midwest, where that's all flat. So, this next slide I just wanted to show you. This is the Port of Longview. And the reason I show it to you is just so you have a feeling of what it is to when our rail cars come in with the pellets, what it has to do to unload into a ship that's going to sit right there. And that is that all this other train traffic has to be gone because we're bringing in 100 rail cars. We have to go into this piece right here, this building right here, and that building is got a huge gate underneath it, and our pellets just open up our gates and it flows right into it. The conveyor system goes through like here, and it connects into here, and it goes up, and I climbed it, it's 300 yards uphill, and we walked out on this catwalk out here, and then it has a big chute that comes straight down into the ship, and takes in, unloads and we do live loads. And the difference in live loads versus just piling it up on that cement right there, which we would have to do if we doubled our capacity, is that the live load is that it saves us about $10 a ton. So if you're doing 10,000 tons, that's a fairly big savings because you're only handling it once. If you put it here, you have to handle it twice. And so we've negotiated a little rate to increase the volume if they would give us a better rate so that we didn't have to eat that $10.
It works for the shipping company because it's costing them $30,000 or $40,000 an hour for every hour that ship's sitting up here.
Oh yeah, let's talk about the marriage, shall we, for just a second?
Yeah.
If we make a mistake on the rail cars, and the rail cars have to sit out, there's some tracks that sit out over here. If it has to sit out there and there's no ship, it's $40,000 a day. But if the rail cars haven't arrived and that ship sits there after 48 hours, it's $200,000 a day.
Mm-hmm.
So economics, you know, this is econ, 1,000 in my mind because it becomes real money, real fast, just by one thing not hitting just right.
Patrick, is this the same conveyor system that moves coal as well?
Yeah, it's a commodity conveyor system.
Okay. I mean, would you have to switch stuff out if you're going to ship grains though, or I mean, how?
Yeah, the grains that have grains and salts, they have to go through a cleansing process, which they do because they used to move salt out of the same facility. Okay. The next one slide here that I show you is that we call this our donut. So here's the epicenter right here. This is where we have our factory, and so literally from Helena to here, it's only 15 miles. So, but the sweet spot for our economics is for our loggers is to come in within 30 miles. The bigger size of our donut is maximum 75 miles. And so that takes in a fairly large chunk. It gives us a few counties and enough wood fiber in that 30-mile radius that we can make the economics happen. And it makes money for the loggers because they can make more runs in a day. So that's why I wanted to give you that part of the feedstock. And then the next one is, so, we love plastic. Plastic's good. Those ones are number ones. Those are money makers for another industry. They pay a lot more for those than I'm going to pay for these. Most of these I'm hoping to get for free. Those we have to pay. They're worth money. Those are number one pet bottles. They go into truck decking, textiles, carpets, you kind of name it. Recycled of those go for about 65 cents a pound. I'm hoping maximum I'm paying 2 cents a pound. So that's, again, the economic. This is how we like to have our logs look when they come in. We have them stacked. They'll all be neat. And I know the owner of this. This is the pulp plant that we were talking about that sits in the, you can't see it, but it sits, the pellet mill sits right behind the stack right here. He doesn't like it when it's out, when his logs are out of the hill, and it drives him. He's a little ADD, that way OCD, he's solved it. And so he likes to have everything in a nice neat row. This is a nice neat row.
Looks good.
It's a little out of character for him, but he gets over it. And but that's how you want to have it look. And the other reason is that when you windrow it like that, you want to let Mother Nature dry out the logs as much as you possibly can before you have to put it in the dryers. It saves you money. The thing to talk about is money.
I got one quick question. I'm looking at the log pile, and I think we talked about this before. So, I mean, can you use some bark or some leaves, or what's the tolerance on that stuff?
We can use bark, needles, but it has to it has to be clean.
No dirt, no soil, no silicate in there. Yeah.
No, it's got to be clean because you start getting dirt introduced into the pellet process, your ash content goes up. You start getting things that the boiler guys do not like, clinkers. And you may have heard that terminology, but the clinker is a bad thing. And so we're in a sterile environment as we possibly can. And our the difference between our mill folks and our factory is that we treat it like a factory. The motors are kept clean, the vacuums are going, things are being wiped down, the filters are being changed. The thermal pictures are being taken on a weekly basis, and I'll identify that thermal picture is that, if you've seen a thermal picture, is that it's basically a camera that takes in, you take a snapshot, it'll tell you where the heat's at, and if you have a nice little, it gets a nice little yellow glow, you're good to go. But if you start seeing that little orange glow, there's a bearing about to go out. What does bearings do when they freeze up? They start fires, it becomes problematic, and I'll tell you a quick story out of the, and excuse my language, but they're dumbasses, pellet plant in Canada, and they killed 6 people, and with a fire, because they didn't keep the place clean, and they didn't keep up on their safety, which is just key to us. And when they reopened the facility, their insurance went from $300,000 a year to $1.2 million. Well, it should have. A little prevention. All you got to do is have one person that's out there constantly cleaning and making sure that everything is going 24 hours a day because you're there. The other thing that we have that not a lot of companies have, we have our own fire department, have our own fire truck sitting there. Our response time is 2 minutes versus, on that last slide, Silver City, the closest to is a volunteer fire department, and their response time is 20 minutes. You might get a couple guys that are there earlier than their fire trucks do, but the fire truck, someone's going to drive to the, and make it happen. So we have our own fire trucks online, foam and water, so that we can, if it's electrical, we can get into right into the buildings doors open up, and we're in. So we figured that out. So those are new revelations, the next generation that I talked about.
Was that fire caught, was it just like dust particles, like an explosion kind of thing? Is that,
It could have been someone, sneaking a smoke. We have a smoke-free campus, you can't even smoke inside a vehicle. And our vendors are the same way. They're caught. They're suspended for 30 days. Happens the second time they lose their contract for a year. That means that the boss is really now upset because he's lost an entire year's worth of guaranteed wages that gets paid every 2 weeks, you know, and it's a big deal. So we're real strict on it, but because we were that strict, I flew back to in the middle of winter with our insurance actuary, showed him our process in Wisconsin, and we got a 20% discount on our insurance. So that $300,000, again, it's talking real money, that's $60,000. That's a person's wages, you know, and the safety of the entire plant. This next slide is, when I was talking about the infrastructure, this is basically some short drawings that just show you our layout of incoming traffic and how things work. And we work with the DEQ to make sure that our air quality is great. We have our safety on hand, but I need all this. Again, one of those 5 cannot be, we can't open up our facility without that. And personnel is really a big deal for us, and so that's why I put down time management is also important because when we have to meet our ship at the port, we have to be on time. That the rail cars have to be back. We have to have them loaded and have them ready to go for the next month. And so it's a fairly big deal. And then there's laws in Montana. You can't log after 7 o'clock at night. Just the way it is, you know. And so you got to follow the time management and work with that time. In the wintertime, it's even harder because the guys only have about 6 hours of time. So you're going to have to deck out 2 months supply ahead just because you're going to have less of volume coming in. And if we have a really deep winter, it's problematic because they can't get in and out. So we've already time managed. That's just a picture of the gensets I was telling you guys about. That's how they roll in. They can commission them in 7 days. Natural gas gets hooked onto them. They turn them on, ask the DEQ to come out and run their probes on them for the commissioning period, however long they want to do that, and you're up and running. It's a beautiful thing.
Do you know what are they probing for in this? And we were just in our previous lecture looking at methane combustion, ideally it's just CO2 and water coming out, but are there other, what are they?
That's what they're looking for, is what kind of particulates are coming out of there.
Oh, particulates too, okay.
Yeah, is there something that in the natural gas, is there something that is generating out of here that is not, because if it was diesel, you're going to have particulates, but natural gas burning so clean, you don't have it, but you still have to go through the commissioning process. They're a group to be reckoned with, but they have a job, and I appreciate what they do. So not everybody appreciates that. Global market. There's the world, folks. That's it. That's my entire market. And I know where everybody who's buying pellets is in this marketplace. Every country I know who's buying, how much they're buying, and how much they're paying for it. That's the global market.
What percentage of your product goes where?
So right now, we don't have our product going anywhere. I started out concentrating on this right here, which is Japan and South Korea. A little bit of China. I still think China, in my predictions, are still within the range that we might see something that from Montana that will go to China in the form of the pellets. They're buying logs right now, so we know that the transportation modes are there. But they think that they have enough wood to make their own pellets, but they're going to go through a learning curve because they're going to try hog fuel, and we all know that hog fuel doesn't work. They're going to go through wood chips. They're going to go through a bunch of things, and they're not going to be able to, it's going to cost them a lot of money because they don't understand co-firing. And I haven't gone into co-firing because that's another lecture. And because co-firing is taking the wood fiber and mixing it with coal. And when you do a reduction and of coal and an increase of the biomass, you can do to upwards to 30% emission reduction by burning the fiber with the coal. So that's another, I hadn't gone into that one too, because it's it takes a little while to get into the paradigm of how it all comes together.
Yeah.
But that's what they're doing in Europe right now. That's what Drax, which is the largest UK power producer, is doing, is that they are co-firing until they get all the way to biomass. So their coal keeps going down like that, biomass goes like this. But like I say, it'll take, in order to show you that, you'll have to see, because we have statistics on it already, because that's how the stack that I showed you at the pulp plant, they started out co-firing. So they learned that they couldn't put in all the chips and sticks and everything else that the pulp mill was generating. They needed to go cleaner fuel. That's the problem. That's why I said it takes on a whole different life within itself. But once you understand it, it goes, oh, sure, it makes sense. So, and then those are the things that this is the business part of it. We need to be paid. Write us wire us the money, put a letter of credit together, we need to be paid. The end of that part of the process, and so it's all good. I'm going to show you one thing just because I think you get a kick out of it. It's a video. So when Levi and I first got the patented rights for Montana and 19 other states, 5 countries, we wanted to make sure that everything that was told to us by the patent holders that we could verify and we could make happen.
You purchased a license to a patent.
Mm-hmm. Yeah. So we hired an engineering company that has probes and computers and everything else that these is in the copper that which now is what copper tape.
That Ed was going to make some food.
Maybe cognac. Yeah, that's enough. And I thought it was
That Ed was going to make some food.
So no ash, no particular,
nothing's coming up.
well, just gas.
Yeah, no more than you see a bigger problem.
Yeah.
So, the particular stuff coming out, so we remember that happened. These things that we record, and that's the fact that that's the food and what makes it, right? Because we got 1650 years of stock, 1650 Well, we do. I can't tell you about it, but I can tell you that it's we took all the data that came out of that computer, and we took all that and we sent it directly to the DEQ, knowing that we could either fall on our sword and die, or we'd be I don't know, you can't call us saints, but we did the right thing. We did the right thing.
Better than the alternative, I assume.
They came back to us about 3 weeks later and it says that they would give us a permit even without having, this is in an uncontrolled environment, which you just saw. In that uncontrolled environment, what happened in that environment was the good stuff. And we even did an ash analysis, and the only thing that we found in the ash analysis that was kind of questionable was that we found titanium in the ash. Oh, damn it. I can just find out where that tree that we burned came from. We could find the titanium. And that was the only weird thing that was in the entire ash. The rest of it was just ready to go into a farmer's field for fertilizer. But in this testing, it was both exciting, frustrating, and scary. And the scary part, the exciting stuff was not seeing any smoke come out. But at 1,350 degrees, we saw smoke come out of the stack. Both Levi and I just were panicked. Holy crap, this is not supposed to happen. And all of a sudden it started to clear up, and we got it hotter, and we're going, oh, I don't know what happened there. And so the next thing, it's cooling down and the black smoke comes out. What is it? It was 1,350 degrees. So that was our put together day. That's where we had to build a grate, so the air could circulate underneath it. We had to have enough holes. The engineers guys figured out how many holes we needed to make the air circulate to replicate the boiler. And so we got into it, cleaning everything up, and we yanked the stack off, thinking that maybe some insulation, you saw the insulation that was around that probe, maybe it got too hot or something like that, and that's what caused it. So we're in there looking around, and we've set the stack over to the side, and the engineering company had gone and gotten a double wall galvanized thing that you see on everybody's roof, and we couldn't find anything, and we grabbed a hold of the stack to see if there was anything inside that had gotten in there somehow, and maybe but anyhow, we melted the double wall insides of the stack. That's what was smoking. We actually got aluminum or galvanized steel to melt. So we went down to Pacific Iron, got ourselves an 1/8-inch mild steel pipe, and we put that on. And but the guy, we kept that stack as a kind of one of those memento, because the next day we never had any smoke, but we wrapped it up. So to wrap this up, what we did, we took the experiment that the engineers did is that we used 2.5 pounds of our pellets and 2.5 pounds of the domestic premium pellets that you could buy, and to do a side-by-side comparison on temperature and burn time. And what happened, what we found in that process was pretty cool. I think in my mind is that we got up to 1,650 degrees. It took 40 minutes to drop from 1,650 down below 1,000 degrees. And so that was documented. And then the other thing that was interesting is that we could only get the premium pellets up to 1,250 degrees. And it went from 1,250 down below 600 in under 10 minutes. So that, to us, told us that we were on the right track, producing power and energy as opposed to heat. Differentiation. Another subject that we can get into, because we can talk about all the type of things of the co-firing and so forth. Coal, on the average, good Appalachian coal is about 12,500 BTU. But it has a high sulfur component that goes away, so that it has to have more scrubbers with it. There's some coal that comes out of Colorado that's supposed to be the clean coal. It has about a 12,000 BTU, depending upon which pocket they get into, and it has a low sulfur, and so it's kind of the premium stuff. They get a little bit more money. The stuff that comes out of eastern Montana, 8,800, low ash or low sulfur, and so we could co-fire with a group that's burning the 8,800, and we could give them a little cleaner burn because it's burning more efficient, hotter. So that's kind of what we do in a nutshell, but I wanted you guys to look at what we have, because it's different. It's where I think the global market will someday be. I will be the first one to tell you that Europe is purist. They think that anything that has a binder in it is bad, and the reasons they think that it's bad is for simple reasons. Russia puts sand in their pellets. What happens when you heat sand?
Glass.
It ruined the interior boilers of the, so it started getting a bad rap. Poland used talc. Additive, put it in there, and give it a little bit of a bind. They call it a binder. Well, so now they came out and says, nothing other than wood, we don't accept it. But they won't open themselves up to looking at newer technologies. And there's new technologies that are out there. Torrefication is a big deal. Black pellets are a big deal. Black pellets are supposed to be somewhat close to our pellets, but only about 8,800 to 9,200 BTU. They're supposed to be water resistant. But to date, the technology has been too expensive to torrefication. It takes more energy to produce the torrefied chip or the pellet than it's economically viable. So if it costs $12 to make a $5 bag, it doesn't work out. So again, those are the type of things that I could go into another hour with you guys if you ever had interest in it, because that's what the market looks like. There's a lot of different things that are going on.
So is it your binders? Is that what you think accounts for the difference between the commercial wood stove pellets and your pellets between 1,200 and 1,650 degrees? Is it the binder that makes a difference in the petroleum?
Oh, absolutely. It's a petroleum product. It's nature at its best. It's releasing the carbons and letting it burn. But it's in such a nice compressed. That's why it burns the longest, because it just takes longer to burn that down. Mm-hmm. And so we're real careful about handing out samples so that people don't put them in their home stoves, because that would be very problematic. And because you could burn out on some of the smaller, the stoves that you see in the living rooms and stuff like that. But we're careful about that. One probably wouldn't hurt, but if someone got a hold of a bag full, it might be problematic. And so we're careful. On the other side, if you come to work for us, every hour during the summertime, springtime, not such a big deal, but our guys are about that big around. So they have 32 holes, I think, in the die. And so every hour, it just needs to be cleaned up. And what comes out of it is this ram thing going up against this the extrusion process, and it makes a pie this big around. Well, the guys in hunting season love it, because they're going to take about 6 of those pies, and they take them out hunting, and it'll last them 3 or 4 days. Pies are over. So they love it. What I have during the wintertime, I take my down to the tailgates when it's cold. People will walk by my fire pit, and they'll go, where did that come from? Because there's not like a log, right? It has a nice big flame on it. Ours doesn't have a big flame, but it just has kind of a nice glow. Because it just, and they'll sit there and they'll warm themselves, and they'll have to stand back. It's great.
And there's no smoke.
Yeah, there's no smoke.
That part would be sweet.
Yeah, totally. Yeah, I have fun with it as much as I can as well, right? Because you might as well. So, anyhow, so that's it in a nutshell. But there's more. So
So most of the sources you're getting this stuff from, is actually like a timber management area? I mean, it's something where they're like replanting it like a tree farm type thing, or?
No, here's what's interesting about, say, the Helen area, and we talked about the private landowners. There's ranchers that are trying to get their rangeland back because, you know, in a nice area, the forest is overtaken their rangeland, and so they want a clear cut. You know, they want it down so that they have some more pasture land for their cattle. There are other ranchers that want to do it so that they're protecting their land, so that they're doing fire mitigation. They're not taking out every log, they're not clear cutting, they're just taking it so that if a fire were to come in, that they wouldn't have to worry about it spreading so fast that they couldn't control it. And then in Helena, they have the beetle kill. They've got so much wood fiber that they're just trying to get rid of it because at some point it is going to burn, or it's going to be, you know, so problematic, you know, for habitat or their cattle to maneuver through that they just want to clean it up. So, and we're gonna see a little bit of that around here, but as you can see, we need to get the beetle kill in our valley. Yeah, little bits, but for the most part, it didn't hit us like it hit Helena. Anaconda. It's been to Georgetown in the last, you know, 2 years. It's sickening, you know, because they just went in and cleaned that.
So same thing for New Mexico and Wisconsin?
Wisconsin is different. Wisconsin is a pulp state.
Okay.
They've got 3 paper mills. Flammable River Paper that you saw the stack on there. They are they produce the white paper for Target.
Mm-hmm.
So the paper you buy from them comes from there. And then down the road, you know, I don't remember the other Wisconsin plants that are there, but anyhow, so they use hardwood, not very much softwood, but they use hardwood, and they get their value of incoming is, so I told you right around $30 a ton incoming to a plant here in Montana. They're talking big dollars, between $90 and $120 a ton. You know, so it's big money to run a pulp mill, and so that was Flammable River Paper Company who went into bankruptcy. Johnson Timber, who I work with and who I have a patent with, they went in and since they had an offtake, a take-or-pay agreement, they ended up with a pulp mill, and the number one thing for them was energy. They killed the other company, and so that's why they put so much money into their own power. You know, and so it was a good investment. You know, they can compete in the global paper market, if you will. So that's why I say sourcing is a big deal. And New Mexico, they have juniper is their bad boy. Juniper's everywhere. So we're taking their rangelands, it's taken over. When it starts on fire during the summertime, it's devastation. You know, it's so hot it'll take out a community, just kind of like we're seeing in California right now. It's burning so hot, it's gone. So, I'm gonna leave those jars for you.
Does it matter what wood you're putting in? I'm sure it does to a point. What kind of wood you're putting into your?
We can go maple species. That's not a problem because we watch our formula, and so we can intermix. And so when we see that there might be a spike in BTU or a spike in ash or something, we can introduce a cleaner chip, or we know what's going on.
Okay, I was thinking like if you got manzanita or something that's an oily wood compared to.
Yeah, we'll be able to adjust the whole formula to do that. And that's what the other pellet plants, they're not able to do. They can't adjust their formula. They just press and go. And pray to God that they don't have any ash in it.
Right.
Or a high level of ash. And then they go through the N1A process, and I can go through that with you as well. I mean, this thing it has a life of its own. So, thanks for listening to me.
Thank you. What's that? Yeah, I'll stop the recording.
Are